you guys were, in reviewing the stuff from yesterday, your data sheet, I found a couple of things that need to be retaught. Right? So you've seen it in simulations, right? You've seen it in simulations, but now you're going to see it live, and you're actually going to do it live. The idea is simple. Watch. I'm going to take my my stopper here, and I'm just going to rotate it around. So first, let's review the basic physics and mechanics going on here. So here I have the stopper. It's going along this path. This is a circular path. Now the motion is going in this direction, right? And then the centripetal force points towards the center, right? Centripetal means points to the center. So the motion is perpendicular. It forms a 90-degree angle to the force. Force is this way, motion's that way. This is a 90-degree angle. It's perpendicular to the motion, right? You got to remember that. So as an object, in this case, moves around, it is perpendicular to the centripetal force, right? Very basic, very simple. All right, now, as it turns this way, which way is the velocity pointing? Right there.
Middle.
Up.
Up, good. It's going in the direction, watch, it's going in the direction of the stopper. So the stopper is moving up, so that's where the velocity is. If I cut the string right here, which way does the stopper go?
Up.
Up, good. Tangent, very good. That's correct. She says tangent. Now, again, watch, the stopper's going up, cut the string, the stopper goes up, also velocity points up. Now, as this goes around, which way does the centripetal acceleration point? To the center, right? Now, just follow my finger. The centripetal acceleration always just points to the center, so it's always just pointing to the center as I move it around. Now, which way is the centripetal acceleration and centripetal force pointing?
To the center.
As well. So the force also points to the center. The idea today, and I wrote it on the objective, is to know that force of tension causes a stopper to move in circular motion. So again, the objective today is to know that the tension right here is creating that circular path as the object moves around in a circular motion. Right? So the tension, when I pull on the string, it gives it tension. That's what creates the path all the way around. Right? So today you guys will be adding mass to the bottom down here, and as you turn it, right, this is the idea, is to get it to turn. What you want to do is you want to turn it to where the hoop, see that hoop on the bottom, is about half an inch or so below the PVC pipe. This is an ideal location right there where you want it. Okay? I'm coordinated. All right? Now, watch. Here's the thing. You're going to have to measure, you're going to have to do several measurements. This right here is known as my what? It starts with an R.
Radius.
Radius. Good. The whole thing is the diameter. Right? Now, we're going to need to take some numbers real fast before you guys start your lab. So on the top, it says, write a hypothesis. Okay? So the hypothesis, I want you to do this instead. Draw this diagram that I have up here. I have weight pulling down on the string. This is my string, right? I have the centripetal force in the form of tension acting on my stopper. The stopper's at the end. So on the hypothesis portion, go ahead and fill that in. Just draw it real fast. Go ahead and fill it in. All right. Now, for right now, there's no need for you guys to write all these formulas. Instead, we'll just notate them down in a different way. And you'll see what I mean in a second. All right, so go ahead and just draw that in. Also, you need to note down that what is it that I said that causes this to move in a circular path? The force of tension. So write that down under hypothesis as well. Force of tension allows the object, in this case the stopper, to move in a circular path. Okay, so fill that in. So make your drawing and also write that force of tension allows the object to move in a circular path. All right, once you're ready with that, then I have something else. Okay, so up here. Now that I've reviewed, you got what you guys have been learning. Okay, and I've discussed what you guys are supposed to write on the hypothesis. Let's look over here. I have your actual lab write-up on the top. Okay, now, real quick, under radius. Okay, radius we already discussed, right? It's this part right here. It's the length. Okay, so you want to measure this length. So what you'll do is you'll get your actual PVC pipe with string and stopper. You're going to take this. Remember, you want it to be about 1/2 inch. That's about the width of your pinky. You want that about right towards the bottom. So like right here. Okay. You want to take that, bring it over here on this side.
My eyes burn.
You're going to use the meter stick to measure the length of the radius. Right? So you're going to measure it. Now, whatever distance it says, let's say it says 25, don't worry. All you've got to do is convert it. So I have that on the board. So meter sticks. Take the number and divide it by 100. Okay? Take that number, divide it by 100, record that number under radius. Okay? So I'm telling you right now, whatever number you get on this side, divide it by 100, write that under radius. Next, take your mass of your stopper. You're going to take the mass of the stopper, you're going to move over here towards the triple beam balance. Lay your stopper on the scale. Record the mass. Now the mass is going to come out like, let's say, 25 grams. Okay? I'm just making that up. You're going to take your mass, so over here. Take your mass, let's say it's 25, divide it by 1,000. And write that number under kilograms right here, under mass of stopper. Okay, so I'm giving you a hint as to how to do this. Take whatever number you record from your scale, divide it by 1,000 to convert to kilograms, and write it right here. So I've written it out all for you on top in green. All right? Next, once you have that down, let's go ahead and figure out how to do the table. Right? So for that comes the actual experiment. Right? So I'm going to go ahead and take my mass. I have some masses up here. And I'm going to go ahead and hook this on to the bottom of my PVC pipe. All right, so now I'm going to go ahead. Now I'm going to go ahead. Now I have some weight here, tension on the string, and the mass is going to go around in circular motion. All right, so let's go ahead and do this. Undergoing circular motion. I want the hoop to be about 1/2 inch away from the PVC pipe. I want the string to be horizontal with the PVC pipe. I'm going to have my lab partners. Okay, my lab partners are going to start, and I'm going to tell them, go ahead and start. I'm going to count 10 revolutions. All you got to do is count 10 revolutions. Have your partner count, time this out. So you're going to use your stopwatch and time it out, literally time it out. Okay, so on this, here, take 0.100, multiply it times 9.8, do that right now, and record that under force. Okay, so take 9.8, multiply it times 0.1, and record that under weight. Yeah.
I got 0.98.
0.98. All right, so put 0.98 here for the first trial only. Go ahead and do that right now. Everybody's going to do the same weight, the same mass. All right, now the time for 10 revolutions. Once you get it horizontal, and what I mean by horizontal is this. I want this stopper to be as horizontal as possible. This is not horizontal, okay? You want it to be like this, okay? Horizontal, as close as possible. You're going to notice yours is going to lag a little bit, and that's all right. Just get it as horizontal as possible. The more you let it lag, the more friction it creates with the top of the PVC pipe. We're trying to eliminate that friction as much as possible. All right, so go ahead and have your partners time it. So once you're ready to go, have them start the time. Let's pretend it takes 6 seconds for it to go around 10 times. Then you write 6 seconds under time for 10 revolutions. Okay? Don't write that down. It's just an example. No, it's something separate. All right. Under period, okay, see where it says period here? You're going to take the time, whatever time you got, divided by the number of cycles. How many cycles did you do? 10. So you write that number here. Okay? So, no, it's your time, whatever time you got, divided by the amount of cycles. All right? Next, find the velocity. You find the velocity by taking 2 times pi times r, right, the radius, divided by the period. And you just got the period earlier. So write that here. So I'm giving you a little pathway so you guys can figure this out. Right? Next, square your velocity. So let's say your velocity is 5. 25 would go right here. Okay, all you got to do is just square it. Write it there. Right? Under centripetal acceleration, okay, right here on this, acceleration. You're going to use v squared over r. Figure that part out. These are all formulas you've already been taught, so you're just reapplying them. And finally, under centripetal force, use mv squared divided by r. Now the biggest problem on that formula, that specific one, is people always ask me, which mass do I use? Do I use the hanging mass, or do I use the mass of the stopper? You use the mass of the stopper. Okay, so just some advice for you, so you guys don't mess that one up. Use the mass of the stopper, use mv squared divided by r. Now you filled out the entire top portion.
Sir,
Okay.
do we have clickers?
Yes. All right. Any questions about the table?
Was one outside too?
In a little bit. Then I'll close the door. Okay. All right. Are there any questions? Hold on. Are there any questions regarding the lab? Okay. No. You guys will be in here.
Is that iPad still going?
Yeah. Hold on. All right. Once you have the table filled out, you're going to add 100 grams the first time. You're going to add 150 grams the next time, and 200 grams for the third trial. Record all your values here. Now, you may not finish your calculations, and that's perfectly okay. Just as long as you at least get your data, the first part of your data here. You need this part for sure. Kareem. All right, so with that said, last thing is lab safety. You don't want to, obviously, when you're swinging this around, you don't want this to hit your face. Okay? If you're not coordinated, let somebody else try it. Right? So, all right, let somebody else try it. Also, watch out with the hanging mass. The mass can fall if you guys are not careful. If you move the string around too much, the masses can fall. So make sure you guys are careful with that, and they'll fall down on the floor. All right? Okay. Finally, hold on. Finally, before you guys are complete this, you're going to click in the back of your lab. Okay? There's a back portion of the lab. Go ahead and turn on your clickers. You can go ahead and start them. All right?